We're going to talk for a little bit about some algebraic expressions and some terms and some properties that we need to know about in order to begin our study of Algebra 2. First, we're going to talk about a numerical expression. A numerical expression consists of numbers, operations, and grouping symbols. An example of a numerical expression would be something like 3 times 5 minus 10 would be considered a numerical expression. Notice there are no variables in my expression, so that's why it's called numerical. We'll get to algebraic in just a second. So another thing that we need to know about is something called a power. It's something that we're going to be talking about a lot this year, and so it's very important that I know that 2 to the 5th is called a power. The number 2 is called the base, so the big number 2 is called the base, and the little number 5 is called the exponent. But the whole expression, notice it's an a numerical expression, and the whole expression together, 2 to the 5th, is called a power. So once again, 2 is the base, 5 is the exponent, but the whole thing together is called the power. And what does 2 to the 5th power mean? We all should know that it means 2 multiplied by itself 5 times. So when evaluating numerical expressions, we use what's called our order of operations. A lot of you probably learned PEMDAS for parentheses, exponents, multiplication, division, addition, and subtraction. Well, I'm going to call it GEMDAS. And G does not stand for parentheses, it stands for all grouping symbols. So first we do operations that occur within the grouping symbols. Grouping symbols can include parentheses, can include brackets, can include those squiggly braces. It could also include a fraction bar. A fraction bar is considered to be a grouping symbol. So when we have a fraction bar in a numerical expression, we do all the operations within the numerator, and then we do all the operations within the denominator, and then we divide last. So after we do all our grouping symbols, next we look for powers. We just talked about what that is. Then we go for multiplication and division, notice from left to right, and then finally addition and subtraction from left to right. So let's look at some examples of how we use our order of operations to evaluate numerical expressions. So this first example, we've got some grouping symbols. We've got -2 plus 5 inside our parentheses. So the first step is I'm going to figure out that -2 plus 5 is 3. And then after that, I'm going to look for powers. I see 3 to the 2nd. So I'm going to say 3 to the 2nd is 9. And notice I get rid of my parentheses because now the parentheses acts as a multiplication symbol. So I'm going to change it to a multiplication symbol. And so then I do multiplication or division, which is the 2 times 9. So I have -4. So we're doing our multiplication. 2 times 9 is 18, and -4 plus 18 is 14. So the value of this numerical expression is 14. Let's do another example. So I see a fraction bar in number 2, and so I'm going to do this fraction bar first. So before I divide, notice I'm not doing anything else with any of that numerical expression except what's inside the fraction bar. So in the numerator, I see that 34 plus 6 is 40. And in the denominator, I see that 7 minus 17 would be -10. And so now I figured out, I added inside my numerator, I subtracted inside my denominator. Now I'm going to divide. So I'm going to say 40 divided by -10 is -4. And now I'm going to go along with my order of operations. So the next thing I see is I've got adding, I've got subtracting, but I also have a power. So I'm going to do -3 to the 3rd power. So we have to be very careful because -3 to the 3rd power. So we're going to be very careful when we raise -3 to an odd power. A negative number raised to an odd power is always negative. 3 to the 3rd is 27. So -3 to the 3rd would be -27. Now I just need to do my addition and subtraction from left to right. So I'm going to say -7 plus -4 is -11. and I have minus negative 27, so it becomes plus 27, which is 16. Now that we know about numerical expressions, we can talk about variables and algebraic expressions. So we all know that a variable is a letter that is used to represent a number. Any number used to replace a variable is called the value of the variable. An expression involving variables is called an algebraic expression. So we're talking about here, we're talking about an algebraic expression like x minus 4. Any number that I use to replace x, for instance, if I said if x equals 2, then x equals 2 would be the value of the variable. And the algebraic expression would be x minus 4. So we can evaluate an algebraic expression if we know the value of the variable. So we can evaluate this negative 4x squared plus 6x minus 5 if we know that x equals negative 3. So we're going to replace x with negative 3. And then we're going to use our order of operations in order to evaluate the expression. So the algebraic expression now becomes what's called a numerical expression because we knew the value of the variable. So I'm going to do my exponents first. I see negative 3 squared. I know that when I square a negative, it always becomes positive. So negative 4 times 9. And I'm going to keep my parentheses there so that I remember to multiply. So I've got multiplication and then multiplication again. So I'm going to multiply negative 4 times 9, which is negative 36. I'm going to multiply 6 times negative 3, which is negative 18. And now I just have addition and subtraction from left to right. So I see negative 36 plus negative 18 is negative 54. And negative 54 minus 5 is negative 59. So we evaluated the expression. We found the value of the expression. Okay, so here's another problem. We're going to write an expression for the total monthly cost of phone service. If you pay a $5 fee and you pay 8 cents per minute, find the cost if you talk 6 hours during the month. So my algebraic expression, and I need an algebraic expression here because I'm finding a cost. The monthly cost of the phone service becomes my variable. So I'm going to say that C represents the monthly cost of the phone service. So I have $5 flat fee plus 8 cents per minute. So there's another variable. There's another variable. So I'm going to use M for how many minutes I talk, because the cost depends on how many minutes I talk. So the cost is $5 plus 8 cents. Notice I have 5, so I can't use 8 for 8 cents. I have to use 0.08 so that I use the same variables. 8.08 times M. I'm sorry, the same units. Okay, so here's my expression, and it says to find an expression. So I really don't need the C equals, so I'm going to get rid of that. I just know that the only variable here is how many minutes I talk. So here's my expression, and so now I can find the cost if I talk for 6 hours. So notice my variable is minutes, so I have to convert my 6 hours to minutes. So how many minutes are there in 6 hours? 6 hours. And in 1 hour, there are 60 minutes. So in 6 hours, there are 6 times 60, which is 360 minutes. So I'm going to do 0.08. I'm going to go to my calculator, and I'm going to do 0.08 times 360 for 360 minutes, and that gives me 28.8. And 5 plus 28.8 is 33.8. So $33.80 would be the cost for talking 6 hours. Okay, so let's look at some more terminology. In an expression like 2x plus 3, 2x and 3 are called terms. I think we all know that. We're just going to remind ourselves. The number in front of the variable is called a coefficient. It's very important that we remember that the number in front of the variable is called the coefficient. Terms like 2x squared and 4x squared are called like terms because they have the same variable part. Now we have to look at the variable. The base and the exponent have to be exactly the same. Terms that are just numbers are called constant terms. So for example, in the example above, 2x plus 3, the 3 is called the constant term. The 3 is called the constant term. We combine like terms by combining the coefficients, and the variable part stays the same. Oops, sorry. Okay, so now we're going to look at the examples of how we combine like terms, and then we'll be done. So I'm going to add 7x plus 4x. I think we all know that 7x plus 4x is 11x. Notice I added the coefficients. The variable part stays the same. Let's go to the next one. 3n squared plus n minus n squared. So which out of these three terms, notice there are three terms, out of these three terms, which are like terms? Well, the 3n squared and the minus n squared are both like terms. The coefficient in front of the first term is 3. What is the coefficient in front of minus n squared? Well, there's no number there, so it's an understood 1. So we have 3n squared minus 1n squared. 3 minus 1 is 2n squared. Notice we subtract the coefficients. The variable part stays the same. Okay, and then lastly, we have to look at this expression. Now I think everyone recognizes a property that we need to apply here, and I think we need to remember that it's called the distributive property. So the first thing we're going to do is we're going to distribute 7 times x squared is 7x squared minus 7 times 3 is 21. And then minus 3 times x would be minus 3x, and negative 3 times 4 would be negative 12. So the first thing we do is we distribute, and then lastly we look for like terms. So I have a 7x squared, and there's no other x squared, so I'm not going to add that to anything. And there's a minus 3x, and there's no other x to the first term, so I'm not going to add that to anything either. But I do see two constant terms. Constant terms are negative 21 and negative 12. So when I add negative 21 and negative 12, I get negative 33.